Welcome to the Oscillator Course 2 of the HT8 MCU Basic Tutorial. This course will take you to understand the external oscillators of the HT8 MCU from three aspects, which are external oscillator introduction, external high-speed crystal oscillator, and external low-speed crystal oscillator. External oscillator introduction. In the previous lesson, we have introduced three internal oscillators, which are internal high-speed RC oscillator, internal low-speed RC oscillator, and internal medium-speed RC oscillator. In this lesson, we will introduce an external high-speed crystal oscillator and an external low-speed crystal oscillator. What is an external oscillator? An external oscillator is an external input source that provides an accurate clock signal, which is usually a crystal oscillator. So what is a crystal oscillator? The crystal oscillator is usually made of a quartz crystal, which is first precisely cut into thin slices, then plated with electrodes and soldered with pins, and finally added with a shell to form a complete quartz crystal oscillator. There are also those made of ceramic, called ceramic crystal oscillators. How does a crystal oscillator work? Quartz crystals, as a piezoelectric material, have a special property. When an alternating voltage is applied on both electrodes of a crystal, the crystal produces mechanical vibrations, and the vibration frequency is related to the physical structure of the crystal. At the same time, the mechanical vibrations create an alternating electric field on the surface of the crystal. In order to take advantage of this property in practical appliances, an inverter and feedback resistor are connected in parallel at both ends of the crystal to form an oscillator circuit. To obtain a more accurate clock signal, we also need to add an appropriate capacitor to the circuit and connect it to ground. In practical applications, crystal oscillators are divided into two categories: passive crystal oscillator and active crystal oscillator, depending on whether they contain an oscillation circuit. As the HT8 MCUs have integrated part of the oscillator circuit, usually only an external passive crystal oscillator is required to form a complete oscillation circuit that generates clock signals for MCU to use. External high-speed crystal oscillator. The external high-speed crystal oscillator of the HT8 MCUs supports a frequency range of 400 kHz to 16 MHz, among which 1 MHz, 4 MHz, 6 MHz, 8 MHz, 12 MHz and 16 MHz are commonly used passive crystal oscillator frequencies. When the FHS bit in the SCC register is set to 1, the external high-speed crystal oscillator is used as the high-frequency clock source. Regarding the circuit, connect the passive crystal oscillator to the OSC1 and OSC2 pins of the MCU. To ensure that the oscillation frequency of some low-frequency crystal or ceramic oscillators is more accurate, it is recommended to add two small-value capacitors C1 and C2 and connect them to ground. As shown in the table on the right, the reference values of external capacitors C1 and C2 connected to the six commonly used passive crystal frequencies are given. The capacitance reference is 100 picofarads for a 1 MHz passive crystal oscillator, and 0 picofarads for 4 MHz, 6 MHz, 8 MHz, 12 MHz, and 16 MHz passive crystal oscillators. For these six commonly used passive crystal frequencies, there is no need to connect an external resistor in parallel because the MCU has already contains an internal feedback resistor RF. However, in other applications where a passive crystal oscillator frequency is used, a suitable external resistor, RP, may also be required in parallel for more accurate frequency adjustment. Additionally, for oscillator stability and to minimize the effects of noise and crosstalk, it is important to ensure that the passive crystal and any associated components are all located as close to the OSC1 and OSC2 pins of the MCU as possible. For more details, please refer to the document of HT8 MCU External High-Speed Crystal Oscillator Application Guidelines on Holtec's official website. For the HT66F3195 MCU, its OSC1 and OSC2 pins are pin-shared with PC0 and PC1 respectively. Therefore, it is required to first set PC0 to the OSC1 function and PC1 to the OSC2 function using the relevant pin-shared control register. Then go on to configure the external high-speed crystal oscillator. In a subsequent course, you will learn how to configure the pins. For the HT8 MCUs, the external high-speed crystal oscillator is configured using the HXTC and SCC registers. Take the HT66F3195 as an example. When the frequency of the externally connected passive crystal oscillator is 4 MHz, how can we configure this external high-speed crystal oscillator to work properly? First, clear the mode selection bit of the external high-speed crystal oscillator, HXTM, to 0, because the used frequency is less than 10 MHz. Next, set the enable bit HXTN to 1, to enable the MCU to drive the external high-speed crystal oscillator. Then, wait for the HXTF flag to change to 1, which means that the clock signal of the external high-speed crystal oscillator has stabilized. Finally, set the FHS bit to 1 to select the external high-speed crystal oscillator as the high-frequency clock source. It is important to note that the startup time of the external high-speed crystal oscillator is affected by the operating voltage. When the operating voltage is 3 volts, the startup time is 25 milliseconds. When the operating voltage is 5 volts, the startup time is 10 milliseconds. External low-speed crystal oscillator. For the HT8 MCUs, the frequency of the external low-speed crystal oscillator is 32.768 kHz. When the FSS bit in the SCC register is set to 1, the external low-speed crystal oscillator is used as the low-frequency clock source. Regarding the circuit, connect a 32.768 kHz passive crystal oscillator to the XT1 and XT2 pins of the MCU. To ensure oscillation and accurate frequency generation, it is necessary to add 2 small-value external capacitors, C1 and C2, and connect them to ground, and also add an external resistor, RP, in parallel. As shown in the table on the right, the reference values of the external capacitors C1 and C2, and the external resistor RP connected to the passive crystal oscillator are given. The capacitance reference value is 10 picofarads for C1 and C2, the resistance reference value for RP is 5 megohms to 10 megohms. For oscillator stability and to minimize the effects of noise and crosstalk, it is important to ensure that the passive crystal and any associated components are all located as close to the XT1 and XT2 pins of the MCU as possible. For more details, please refer to the document of HT8 MCU External Low-Speed Crystal Oscillator Application Guidelines on Holtec's official website. For the HT66F3195 MCU, its XT1 and XT2 pins are pin-shared with PB0 and PB1 respectively. Therefore, it is required to first set PB0 to the XT1 function and PB1 to the XT2 function using the relevant pin-shared control register. Then go on to configure the external low-speed crystal oscillator. In a subsequent course, you will learn how to configure the pins. For the HT8 MCUs, the external low-speed crystal oscillator is configured using the LXTC and SCC registers. Take the HT66F3195 as an example. How to configure the external low-speed crystal oscillator. First, set the enable bit LXTN to 1 to enable the MCU to drive the external low-speed crystal oscillator. Then, wait for the LXTF flag to change to 1, which means that the clock signal of the external low-speed crystal oscillator has stabilized. Finally, set the FSS bit to 1 to select the external low-speed crystal oscillator as the low-frequency clock source. Note that the startup time of the external low-speed crystal oscillator is 1000 milliseconds when the operating voltage is either 3 volts or 5 volts. Course summary. In this course, we have learned the crystal oscillator's principle and category. The frequencies. External circuits. And register configuration of the external high and low speed crystal oscillators. Through the study of this course, you will have a certain understanding of the external oscillators of the HT8 MCUs. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.